Hi friends, previous videos I have explained about the fuel system and the lubrication system, and in this video I am going to explain about one more critical system of the internal combustion engine, that is the cooling system. Considering the length of the subject, I split the videos into two parts, that is part A and part B. In the part A I am going to explain about the thermal efficiency of an internal combustion engine and which are all the thermal losses in an internal combustion engine and what is the net power available at the flywheel, that is the useful power. In the next video I will be talking exclusively on the cooling system. Friends, before talking about the cooling system, let's have a look on this figure. This is the combustion chamber of the engine. In any internal combustion engine, the chemical energy from the fuel is converted into the thermal energy, and the thermal energy again is converted into the mechanical energy by moving this piston, then by the crankshaft, and the energy is available at the flywheel. Okay. Fact is, the complete fuel energy will not be converted into the useful energy, that is flywheel energy. Whatever the energy is obtained by burning the fuel is not going to be converted into the mechanical energy 100%. There will be so many losses of the energy. So which are all those losses and all we will discuss. For your information, the effective mechanical energy available at the flywheel is 42 to 43% in the present generation engines. And what about the balance 58% of the power? The balance 58% of the energy is wasted through the exhaust gases. Majority of the energy is wasted through the exhaust gases. Then through the heat transfer from the cooling system, because engine has to be cooled regularly. So what certain amount of heat is carried through the cooling system. Same way, certain amount of heat is carried or wasted through the lubrication system, and some amount of heat is wasted through the friction. Means the engine contains so many moving parts: pistons, crankshaft, connecting rods, turbocharger, valves, this fan, water pump. So many things are there. To move all these things, certain amount of mechanical energy, certain amount of frictional energy will be consumed. Okay, this is called frictional loss. Thermal efficiency of an engine. What is meant by the thermal efficiency of an engine? Thermal efficiency means amount of energy available to perform the work here in the flywheel. The amount of energy available to perform the work, that is energy available at the flywheel, over the total energy contained in the fuel used. So whatever the energy is available divided by the total energy contained by the fuel burned in the combustion chamber. Okay. As I explained to you, the present generation diesel engines designed with a thermal efficiency of 42 to 43%. At the flywheel, if the 43% of the power is available, and what about the energy available at the wheels? In between, from flywheel to the wheel, there are so many losses again: clutch, gearbox, steering, propeller shaft, differential, final drives, and the rolling resistance of the tires against the ground, and also the wind direction opposite to the vehicle. By taking out all these losses, frictional losses, the net available power to the wheels will be maximum by 24 to 25% of the energy obtained through the fuel. You can see this figure, it shows the heat distribution. Okay, the around 25% of the thermal energy or heat energy is lost through the exhaust gases. So again, if you break up the exhaust loss through the exhaust gases, direct heat loss in the exhaust gases, chemicals in the emissions, means whatever the chemicals the diesel contains, those chemicals are exhausted out. Pumping losses, pumping the exhaust gases out, pumping the fresh air inside the engine. Then again, the restrictions in the exhaust passages, this is called the back pressure, and the energy required to run the turbocharger turbine. These are all the exhaust gases loss. Then around 7 to 8% of the losses will be on account of the friction. I explained you, running the water pump, running the turbocharger, running the camshaft, running the crankshaft, piston, ball train, fan, so many other moving parts, and also lube oil pump. Then around 25% of the heat energy is lost through the cooling system and lubrication system, because these liquids always will carry the heat along with them and dissipate into the atmosphere. Then the net available energy at the flywheel will be around 43%. So I told you all what is meant by thermal efficiency. Then the present generation engines are being produced with thermal efficiency of around 43%. And if we go back, the engines produced in 1960s were operating with 32% thermal energy and 68% losses were there on this account. And the engine produced by the diesel in the beginning was having 17% thermal efficiency because its size was very huge and the power obtained was the flywheel was very minimum. So balance around 83% power was lost on account of all these activities. Now the engineers are aiming to reach the thermal efficiency to 55%, means increasing the thermal efficiency, minimizing the losses. So how the thermal efficiency can be increased and which are all the factors affecting or influencing the thermal efficiency? The quality of the fuel, one of the influencing factor of the thermal energy, and its additives. What is the quality of the fuel? Calorific value, ignition quality, sulfur content, specific gravity of the fuel, water content in the fuel, and the flash point and carbon residues, etc. Next comes fuel injection pressures and fuel injection technology. You can see the old model engines are with mechanical injection system. Now the more engines are coming with electronic injection system, so which works with very high pressure injection with the precision governing mechanism, so that the optimum amount of power can be obtained from the every drop of the fuel we burn. Then comes to fresh air charging system. So how the fresh air charging system is influences? The density of the air varies depending on the altitude of the place where we operate. As we go at higher altitudes, the density of the air drops, so the oxygen content also is dropped. When the oxygen content is dropped, naturally the power also, engine power also gets affected. Okay, so that's why the intake, charging air intake are also is important. Next, exhaust gases also influences the thermal efficiency. Then cooling system, and also the coolant, mainly the coolant and additives and the other parts involved in the cooling system. Then the lubricating oil quality and its additives. Okay, additives in the sense whatever this, as we discussed in the lubrication system, all these additives. Then engine components and its design. This is a simple diesel engine, conventional diesel engine, naturally aspirated diesel engine, okay, older model engine. So this engine produces around approximately 10 kilowatts power, but the weight is very bulky. And if you say the modern car engines, the weight is very less because their head is made with aluminum and engine is fitted with turbocharger, aftercooler, so many things and all. So in compact engine, the higher power is produced. In the bulky engine, lower power is produced. So this is called power to weight ratio. What is meant by the power to weight ratio? This is the ratio of the engine power output, that is in kilowatts or horsepower, to the weight or mass of the engine, that may be in kgs or lbs. For example, an engine weighing 2000 kilograms produces around 300 kilowatts. Its power to weight ratio will be 300 divided by 2000, that is 0.15. If we can produce the same engine, that is 2000 kgs engine, around 350 kilowatts, its power to weight ratio will be 0.175. So we have increased the power to weight ratio by optimizing the fuel consumption, by charging the more air to the by adopting the latest technology in the fuel engine system, and so many things. So the power to weight ratio also it factors the thermal efficiency of the engine. Kindly go through these 2 pages notes. If you have any queries and questions, it's my pleasure to clarify the same. You can contact me through the email.